5, 6 is all about inequalities. What's an inequality?
More than, less than.
Less than, greater than, less than or equal to, greater than or equal to. This is going to be less than or greater than involving triangles, okay? Inequalities in triangles. So there are a couple properties, theorems that we need to talk about, and then I'll get to the fun stuff in just a minute. The first is, it's called the comparison property of inequality. You will never have to tell me that name in a proof, in anything. It's just something for you to understand. This is what it says. If A is equal to B plus C, and C is greater than 0, meaning C is a positive number, okay? So, for instance, pretend that C is the number 2. If I say A equals B plus 2, which one of those numbers has to be the bigger number? Your A or your B? A would have to be bigger, right? If your C is a number greater than 0, you're adding something to B to make it equal A. So A is greater than B, okay? Where that comes into play is this little corollary. So we learned the triangle exterior angle theorem. Remember that? Your two remote interiors added together equal your exterior angle, okay? This is a corollary to that. This is an add-on. So whenever you see corollary, it just means add-on, extra information, okay? This one says the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. In other words, we're saying this angle by itself is bigger, so angle 3 is bigger than angle 1 or angle 2 because we have to add 1 and 2 together to equal 3, right? So that means 3 has to be bigger than 1 and 3 has to be bigger than angle 2. Does that make sense? If we have to add them together to equal 3, then those 1 and 2 have to be smaller than 3 by itself, okay? So the reason they give you that is so that you can understand what's going on here. The question here, they don't give us any angle measures, right? We know nothing other than this triangle is isosceles. They give us those markings. The question is, how do I know that angle 2 is bigger than angle 3? And you can't just say, well, it looks bigger. I know it looks bigger. Pretend it doesn't look much bigger. How do I know that 2 is bigger than 3? Take a look at it, think through it, see if you can come up with a reason. Anyone want to take a crack at it? Okay, can anyone tell me anything about any of these angles? John?
Is 3 and 4 added together congruent to 1?
We can say the measure of angle 1 will equal the measure of angle 3 plus the measure of angle 4. The reason we know that is the triangle exterior angle theorem. Sorry, I'm highly abbreviating here. Triangle exterior angle theorem would say that 1 is equal to 3 plus 4, because that's an exterior angle. Anything else you know in this picture? Why did they tell us this? It's not going to be one of those, because we're not proving two triangles congruent. So we can't do that. If we know a triangle is isosceles, Abby.
Then the two angles equal the same.
Which two?
1 and 2.
Yes, we know that angle 1 is equal to angle 2 by the isosceles triangle theorem. Okay, so if I know 1 is equal to 3 plus 4, and I know 1 is equal to 2, then I can say the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4 by substitution, right? I just substituted the 1 or the 2 for the 1, right? I took this 1 out and I put a 2 in its place. So I get this. Well, if the measure of angle 2 equals 3 plus 4, the comparison property of inequality says that 2 is therefore bigger than 3. Okay, so the measure of angle 2 is greater than the measure of angle 3 by the comparison property of inequality. Okay, so it's really just recognizing how the different angles relate to each other in the problem, and essentially you're walking through a proof there. I don't make you do any of those proof type problems where you have to explain it all to me. There is one in the homework, I think, but you don't need to do that on a quiz or a test. So if you don't remember the name, comparison property of inequality, that's okay. I need you to understand the concept of it, how the numbers relate to each other, okay? Okay, here's the fun stuff. Theorem 510, no, you don't need to remember the name of it. Here's what it says. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. Okay, here's what I mean. If I have this triangle, and this is X, Y, and Z, basically what we're saying is if XZ, okay, the length of XZ is greater than the length of XY, okay, which you can see in this picture it is. If XZ is longer than XY, then the angle across from it is bigger than the angle across from the other. So if that is the case, then the angle across from XZ, which is angle Y, is bigger than the angle across from XY, which is angle Z. Okay, now I think that makes a lot more sense when you see it with numbers. So let me show you in this example. What they're going to ask you to do is to list your angles, okay? And here's on the quiz and the test, this gets done wrong all the time. It's really quite annoying because people just don't read directions. How do you name an angle? Do you use 2 letters? No, never. I'm not asking for segments. I'm asking for angles. List the angles. On the quiz, I bold and italicize it. The angles from smallest to largest. John, what's up?
I was gonna ask, like, when you do the angle, is that the little greater than the less than sign that you're doing, or is that the triangle?
This right here, I'm saying angle Y
Okay, so it's not like.
is greater than, this is greater than,
Okay.
and this is angle.
Okay.
So,
It's confusing me.
yeah, sorry, angles and greater thans. Yes, angle Y is greater than angle Z. Is that better? Okay. So we want to list the angles from smallest to largest. Some of you are going to be tempted to tell me that CB is the smallest. CB is a segment. I don't want the segments. I want the angles. So yes, CB is the shortest segment, which means which angle is the smallest angle? Angle A, the angle across from it. Okay, so angle A would be your smallest angle. So what's your next smallest angle? What's your next shortest side? The 6, right? The angle associated with the 6 is the angle across from it. So that's angle C. And then your longest side, the 7, the angle across from it is the B. So if we're listing our angles in order, it's angle A, angle C, and angle B. Does that make sense? Yes? Okay. Theorem 511 just kind of reverses that. Theorem 511 says if 2 angles of a triangle are not congruent, then, I write the wrong words for you. then the longer side lies opposite the larger angle. Okay, so it's gonna look nearly identical. If you had a triangle like this again, X, Y, and Z, now we're gonna say, if I know angle X is smaller than angle Y, this is our less than, the other ones are angles. If angle X is less than angle Y, then the sides across from it, so across from X is YZ, will be less than the side across from Y, XZ. Okay, so it's always the angle and the side across from it, the angle and the side across from it, the angle and the side across from it. That's the relationship we have. So now on this one, it says list the sides from shortest to longest. Anyone see what we need to do first? How do you figure out your shortest side? John? No. What? The smallest angle is across from your shortest side, but we're missing an angle. How do I find what angle T is? A triangle has to add up to 180. So 58 plus 62 plus X has to equal 180. So that means X is going to be 60 degrees. Okay, so first thing, find all angles. Now list your sides. So what is your shortest segment right now? T what? TV. Across from the 58. The smallest angle is across from TV. So TV is the shortest side. What's the next shortest side? UV. The next smallest angle is the 60, and across from that 60 is the UV. Okay, and then your longest side is across from your biggest angle. So that would be TU or UT. It doesn't matter what order you do them in, but this would be those angles in order. Any questions on that? Okay, if we have a little more time at the end, I'll try to show you another set of those if you need them, but that's the process every time. Do you feel like you jumped into the 80s right here? Because I feel like those colors together look very 80s to me. Okay, so there is another theorem. It's called the triangle inequality theorem. And basically what this one says is the sum of the lengths of any two sides of a triangle is greater than the third side by itself, okay? So basically it's saying this: if I took X, Y, and YZ and I added them together, that has to be longer than XZ by itself. If I took XZ and XY and added it together, it has to be bigger than YZ by itself. So any two sides added together will always be bigger than the third side by itself. Doesn't matter which two you do, it should always be bigger, okay? So that helps us in determining if different segments can form a triangle. Actually, before I do that, let me just show you why. Let's say this is a length of 5. If I were to take a length of 2 and a length of 3, if I put my 2 here and my 3 here, they would never meet, because if I hinge that, the only place they'd actually meet up is when they're flat, right? 3 and 2. So it has to be that those numbers together are longer than the third side. Does that make sense? Can't even equal the third side, because when they equal the third side, they meet perfectly in a straight line. The second you hinge that up, they move away from each other, okay? So look at these lengths, 3, 7, and 8. Basically what we're saying is the two added together have to be bigger than the third, but you got to check every setup. So 3 plus 7 has to be bigger than 8. 3 plus 8 has to be bigger than 7. And 7 plus 8 has to be bigger than 3. Right? You just do every combination that you can. The two added together have to be bigger than the third. Are all of those true statements? Yeah, 10 is bigger than 8. 11 is bigger than 7. 15 is bigger than 3. So would that make a triangle? Yes, it would. Okay. So look at letter B. Is that going to make a triangle? No, because right off the bat, 3 plus 6 is not greater than 10. So this would be no. You don't have to check all three of them. If you find one that doesn't work, that's proof enough that it's not going to make a triangle. Okay? So add them together, see if it makes 3 true statements, and then you're good. Okay, so this uses that idea, but now they only give us 2 of the sides and they don't give us the third side. But what it says is a triangle has side lengths of 8 and 10. What are the possible lengths for your third side? Any thoughts on how you could maybe figure that out? John? Okay, so if you add 8 and 10 together, you'd see what they're less than, right? So 8 plus 10 has to be greater than that one side by itself, right? So if you flip that around, x is going to be less than 18. Anyone know what the low end would be? Julia. Okay, so if we're saying it's less than 18, we're saying it's greater, 3 would work, right? So we're gonna actually say it's greater than 2, because anything greater than 2, 2.5 would actually work also. So anything greater than 2, that doesn't include 2 and it doesn't include 18. Here's how you figure it out, okay? We said we set up 3 inequalities. One of those inequalities is 8 plus 10 is greater than x. Another one would be x plus 8 is greater than 10, and x plus 10 is greater than 8. Well, if I solve those, x has to be greater than 2. If I solve this one, x has to be greater than negative 2. Here's the 2 ways you can tell. A negative doesn't make sense because you cannot have a negative side length of a triangle. And if it has to be greater than 2, it's going to be greater than negative 2. So get rid of the negative one. The 2 you're left with will be your range. So if we wanted to set it up as one thing, we would say 2 is less than x, which is less than 18. Okay? Does anyone see a quicker way than setting up 3 inequalities there? How did we get 2 and 18 from 8 and 10? Add them together, subtract them, right? If you add them and subtract them, hey, I'm working over here. If you add them and subtract them, you'll get your numbers. That's all you got to do. So if I said your numbers are 6 and 11, what's your high end? 17. What's your low end? 5. Add them together, subtract them. This would be your answer. Isn't that lovely? Okay, last thing. I want to know which segment in this picture is the longest. And this one's always tricky for people because it doesn't feel like it makes sense. But it makes sense when you figure out what's going on. First of all, you have to find your missing angles. Okay, so can anyone tell me what this angle ADB would be? That's 60. To add up to 180, 59, 61, and 60 adds up to 180. Can anyone tell me what angle C should be? 63. To add up to 180, 57, 60, and 63 will add up to 180. Okay. Which segment is the longest? It's not a trick question. Feels like a trick question.
That's 68 or 60?
This is 60.
BC.
BD.
I say BC.
You're both wrong.
Yours is straight for me. C. Yours is straight. BC. No, not BC. AD.
Okay, look at the triangle on like the bottom left. Here, here, and here. Which segment is longest? 80, across from the 61. Okay, So in the left triangle, AD is the longest. Now look at the right triangle. Which side is the longest? BD, across from the biggest angle, is the biggest side, right? This side. So people always go, well, that one's 63, the other one's 61. 63 must be bigger. But if these are all 60, and these are 61, 59, and 60, this is across from 59, and it's this long. This is across from 60, and it's only that long. So the number itself does not get impacted in two separate triangles. In this triangle, which segment, orange or blue, is longer? Blue is across from a 59-degree angle. Orange is across from a 61-degree angle, right? So once you find the longest in both of them, you need to find the triangle that contains them both and then ask, okay, which one is actually longer in that triangle? This would be AD. Does that make sense? Hopefully. Okay.